Okay, so what we are going to do in this video is essentially to send and receive a message using connectionless sockets. So I have a sender process that's going to send a message and to a process running in another machine, and the other process, which is the receiver process, is going to receive the message and just print it out. Okay, so it's just communication from a sender to receiver. They cannot even communicate in both directions. We'll see after this another video where we can communicate in both directions, but in this example you're just going to send a message from one process running in one machine to a process running in another machine. So I have the programs here. So first let's go look at the receiver program, because in your socket programs always you should start when you execute the projects, you should always start the receiver program first, because whenever you want to send something, the receiver should be on and running, so that the sender can send something and whatever is sent will be received. So if you try to send something and the receiver is not running, the message will be dropped. So even in day-to-day life, when we speak, the listener, whoever you are telling something, has to be willing to listen. It is willing to receive. If the person is not willing to listen or receive, then whatever you send or speak is not going to be received. So likewise, we should start our receiver first. So that's why we are going to start looking at the code from the receiver point of view first. So this is a separate receiver program. So you always write two programs most of the time, unless in multicast case you could just do one program, which we'll see later. But in the Unicast communication using both connectionless and connection-oriented sockets, we'll write two programs. One will be the receiver program, the other will be the sender program, or a client program or a server program, depending on the case. For connectionless sockets, which is using datagram sockets, we'll use the terminology sender and receiver. Sender sending something, receiver is receiving the message. Now, so let's start with this. So Datagram Receiver. So before that, you should also import these two packages, java.net and java.io, and you put .star, which means you are basically importing everything within that package io and within the package net. So this is a standard way of declaring the main function in Java. Okay, so class Datagram Receiver, public static void main, and then I'm going to pass some command line arguments to run these programs. So I pass string args, which is a kind of an array of strings. Now I always put all my code inside a try-catch block, because you will be using methods that are part of this IO class or the net class. So there will be possibility that they can generate exceptions if an input is received in the wrong format, or if the socket is closed on the other side. You're trying to send a message to a port on the other side and the port is closed, socket is not open, and all these things could lead to a lot of exceptions. So you want to catch those exceptions and handle it specifically, but in this case we just want an error message to be displayed, and then we'll go and debug the program and fix the error and then proceed. So I put everything in a try-catch block, and so whatever the exception is being generated, I kind of catch it as an exception of this class exception, which you know is a super class of all exceptions. So I can just then say this E is any name you can give for the exception object that you want to catch, and I can then say that E.print stack trace, that's going to print the history of that error, from where it originated, from where that method was called, and from which line the error originated, and so on. Okay. Alright, so that's basically used for debugging. So if your program does not have any error or does not generate any exception at runtime, you're not going to face that. But most likely you will face it, at least when you're trying the programs. Okay. Alright, so this is message-based communication. As I said, this is connectionless sockets, so we're going to send and receive in terms of messages. So which means we should specify what's the maximum size of the message we want to receive. So the receiver can specify that. So in order to specify that, I start declaring an integer I call it as maxlen. You could name it anything, it's just a variable. And this 40 here indicates the number of bytes I could accept, or the number of characters you're going to send and receive in terms of characters, and each character is a byte. Okay, so character and byte are the same here. So we are specifying that max length, which is the maximum length of the message we could receive, is 40 bytes. Then I'm going to run this receiver on a local port. So which port I want to run, that could be assigned by the user, as we'll see. And that integer value for the port number, I am passing it in command line. So I get that as a string as part of this args array, and then I do this integer dot parse int, and I basically now have it as an integer. So now Datagram socket is the name of the class, and I am creating an object of this class. So this is the name of the object, my socket, and this is the constructor. So new Datagram socket, or creating an object of this class, and this constructor takes one argument, which is an integer argument that specifies the port number on which you want the receiver program to be run. Okay, so so once you run the socket, once you call this constructor, so basically the socket will be bound to this port number. So on the same machine, you cannot create another socket on the same port number when this one is active. So only after you close this particular socket at that port, you can open another socket on the same port. Okay, so right now we have opened one port. So that's one socket. So on this port. So that's why the port number that you use to open your socket should be carefully chosen. The well-known processes like TCP and sorry, not TCP, like FTP, HTTP, and all these things. Let me increase the thing. The well-known processes like FTP runs on port 21, HTTP runs on port 80. Secure Shell, I believe, runs on port 22, Telnet runs on port 23, and so on. So the well-known processes have a specific port number. Okay, so so for the user-defined processes that you are creating, like this Datagram Receiver and all these things, you should not run them on the same port number. So as I just said, you cannot run more than one socket on a particular port. So that's why for the user-defined processes, you should run them on port 1024 or above. Okay. So the port number field in the packets will have 16 bits for the port. So you can really have 2 to the 16 minus 2 to the 16 minus 1 number of ports. So anything about 1024 to 2 to the 16 minus 1 should be fine. So for your projects, you will run your processes on ports which are 1024 or above. So for that, what I did is, each of you should use the last 4 digits of your J number and as your port value. So if the last 4 digits are something like this, that's well and good, it's about 1024. But if your last 4 digits is something like this, then what you should do is you should add sufficient value, either add 2000, 3000, whatever you want to add, and hopefully it doesn't clash with anybody else's port number. Use that as the port number. So make sure it is 1024 or above. Okay. All right. So so this constructor basically opens a socket or creates a socket and binds it to that port number. Okay. So then what I do is I create a byte array. I call it as buffer, and I create it of size max length. So this is the buffer or the byte array we are going to use to store the incoming message or the packet, okay, the contents of the packet. So now the second class, as I said, we'll be using in connectionless sockets is Datagram Packet. So Datagram Packet is the class that we'll use to kind of refer to the packet that we really want to send and receive. And this is a constructor, and it takes 2 arguments: the buffer, the byte array that we just created, and the maximum length of that buffer, the byte array. Okay. And then what you do is you call this receive method. So this is a very important method. The receive method on this datagram socket object, and pass this datagram packet object, which I call it as packet. You could name it anything you want. I just call it as packet as the argument to this receive method. So this receive method is like a binding call. A binding call means until you receive something, the control won't, sorry, blocking call. Sorry, I should not call it binding call. You could call it binding, but it's better to call it as a blocking call. The receive method is like a blocking call. I'm sorry. So a blocking call means, so far it is sequential, right? So you execute the lines one after the other. So once the control goes to this line and executes the receive method, until you get a packet, the control is going to stay at this line. It's not going to proceed further and execute all these lines. Okay, so somebody should send a packet and the receiving process should receive it at this time. So this is the time now we should look at the sender program and see what it does to send a packet, and then we'll come back to the receiver program. So the sender program is structured similarly. You import java.net and java.io, and the class and main, everything is the same, and all the code is put inside the try-catch block. So in order to send someone even an email or a postal mail, what you need to know the receiver's mailing address, and that includes several things, of course, but in our case, let's do computer-based communication. We need to know the name of the machine. Specifically, as we have already seen IP addresses, we need to know what the IP address of the machine on which the process is running. Okay, so this inet address is equivalent to this IP address. The IP address is basically represented in class inet address for Java, and the port number at which the process is running. So we need the IP address of the machine on which the process is running and the port number assigned to that process on that machine. So IP addresses are not that easy to remember, and sometimes you may not even know the IP address of a machine to which you want to communicate. But what you may know, or you should know actually at least, is the domain name. So for example, www.jsums.edu is the domain name. Okay, so what you should know at least is the domain name, like www.jsums.edu or cnn.com. So these are the domain names. So once you enter these domain names, internally what happens is there will be like a name resolution that your computer will try to do, either by itself or by contacting a domain name service, a server that provides the DNS domain name service, and kind of resolves the domain name to its IP address. So you have to find the IP address of the web server, for example, in this case, for jsums.edu. So you need to know the IP address of the machine anyway. Okay. So likewise, you should also know the port number at which you're going to run the process, the receiver process that's going to receive the message. The third argument I am passing here is essentially the message I want to send. So you could use scanner or whatever in an interactive fashion to receive the message, but here to get the message from the user that you want to send. But in this example, I'm just going to pass the message also in command line. Okay, so given that you got all of this, now I'm going to open my Datagram socket. I'm going to create a socket on my side, and I call it as my socket from the sender side. And notice here, unlike the receiver case where we also use this Datagram socket constructor, I did not use a specific port number, because this is basically corresponding to the port at the sender side. So it's actually two things here, right? So the sender running on an IP address and a port, and the receiver running on some IP address and a port. So the IP address could correspond to something like this, and the port could correspond to something like 10, 2, 3, 4. Whereas this sender could run on something else, could be on something like this, and the port could be something else. Now, the port that you need to specifically assign to that socket is going to be this port number on which you want to run the receiver program. And the port numbers on which receiver programs wait should be known publicly to everyone. Why? Because anyone could send a message to that process. So everyone should know what is the port at which that process is running. Whereas if you're just going to send a message, like what we are going to do in this example, as a user, you are not concerned that much on what port that socket is open to send that message. Like what we are doing here is basically opening a socket. I'm just going to send a message from that machine. I'm not concerned about on what socket on what port I want to open the socket. So basically, I don't need to specify any port number here, but it needs to be opened on a particular port number. So if you don't specify any port number here as part of a constructor argument, what happens is the operating system is going to assign a particular port number for that socket at the sender side. So if you don't specify some number like this, the operating system is going to allocate any available port number and open the socket on that port number and send it. So in order to send something, you need all these four: the IP address of the sender side and the port number of the sending process, and then the IP address of the receiver side and the port number for the receiving process. You need all the four. Okay. So now what you're going to do is, since as you saw here, we are going to store it as a byte array. So that's the way convention for sending information using connectionless sockets. So we are going to transform this string, which is by name message here, as a byte array. So the dot get bytes method is going to convert that string to a byte array, and I'm storing that in a byte array by name buffer. And now I'm packaging my packet. So Datagram Packet is the name of the class to send the packet, and it's a different constructor than what we do here. So as you might see in the API for Datagram Packet, it has different constructors. So you just use a constructor that you want to use. Okay, so these are different constructors. So whatever the constructor that is applicable for the thing that you want to do, just use that constructor. So here I'm using the constructor that takes the message, basically the byte array, and its length, and the IP address of the receiver host and the port number for the receiving process. So when you send a message in the envelope, you need to specify the receiver's address, right? So that's what we are doing here. So in the packet, we are creating the packet, Datagram Packet, with a constructor that has the receiver's IP address and the port number and the contents of the buffer and the length of the buffer. And then I call the send method on the socket, Datagram socket, and pass the Datagram packet object, the packet object. And then I don't need to do anything in my sender program, so I can just close the socket. So as a good programming practice, you should always close your sockets once you're done with them. After you're done with whatever you want to do with them and you don't need them anymore, you should close your sockets, so that when you close the socket, the port number that was assigned to that socket will be released and could be assigned for any other process. So now let's go to the receiver side. So the receiver side is going to receive this packet, and so when that packet really comes to receiver, once it is sent from this side, the receiver is going to really receive the packet, and that's the time this call, the program basically will be unblocked. So until then, the program will be kind of locked, and it won't run further. But once that a packet is received, it will be unblocked, and then you execute the rest of the lines. So the packet is now received, and as you can see here, the contents of the packet are stored in this buffer now, and using that byte array buffer, we are getting back it as a string. That's what we are doing. So this is the constructor for string. Of course, strings could be created using different constructors. So this is one such constructor for strings. So new string of this byte array, and then now it is a string, and I can print the string. And now also I don't need to do anything with the receiver socket. It's just return. We have developed this program to just accept one message, print that message, and then stop. So now let me go and show the execution of these two. Now we are not going to use two different machines to run your programs. You could do, if you go to the lab, you could use redhat3.jsums.edu. So redhat3. So the receiver or server could be typically run. So in a lab environment, the sender is like the local PC, and the receiver could be run on redhat3.jsums.edu, which you should have used for your 118, 119 classes. But in a personal computer environment, you will use localhost for both sender and receiver. So let me show you how to run in both cases. Of course, I'm not going to be able to connect Red Hat 3 from where I am now, but I'll show you how to run it at least. Alright, so we first need to compile those programs. So let me compile my receiver program. And if you're not sure of how to set up the Java path, I have posted another video that shows you how to set up the Java path in Windows 7 environment. So this is compiled. So but what I'm going to do is, so if you're running this in a local environment or even in a lab environment, make sure you put your programs in two different folders. The sender program is in one folder and the receiver program is in another folder, so that you can clearly see the effect of sending something and receiving something, at least even in localhost. So they could be in the same folder, but you don't need to. This will give you this kind of clarity that I'm sending something from one machine and receiving the message on another machine. Alright, so it's compiled now. So I'm going to start the receiver. Again, as I said before, between the sender receiver, you should start the receiver first, because the receiver should be on and running before you can send something. So if you look at the receiving process, the only argument it takes is the port number at which you want to run the receiver. So I'm going to start the receiver, Java Datagram Receiver. And so why Datagram Receiver? This is the name of this class, Datagram Receiver, that has the main function. Okay, so that's why I passed Datagram Receiver, the name of the class that has the main function. And then I'm going to just use 1, 2, 3, 4 as my port number. And you can see here the program basically is waiting for something, and this waiting is due to this blocking call. The program has executed all these lines, and it is now currently on this receive method line, and it is being blocked because no packet has been received yet. It's just waiting for a packet. So that's the time you should start your sender program. And the sender program, as you can see, is taking 3 arguments: the name of the host and the port at which receiver process is running and the message you want to send. Now this is where, if you want to run it on a lab environment, so this is the name of the class, Datagram Sender, where is the main function. So if you run it on a lab environment and you want to use Red Hat 3 as the receiving machine, you could do that. redhat3.jsums.edu, and the port number, whatever the port at which you're running the receiving process, and the message you want to send. This is a message on sockets or something like that, whatever the message you want to send as a string, and make sure it is within 40 characters, because that's the length you have set for a message in your program, right? Now I'm not connected to Red Hat 3, and I'm not running my receiver also in Red Hat 3. So what you should, if you cannot do that from your home or DOM or wherever you are, then that's the time you can run both of these programs on a local host, as I'm doing. So I'm running both my receiver and sender on my same computer. The only thing is I'm putting them in different folders just to create an effect that they are running into different machines. Okay. But localhost is, as I told in class, is runs on the 127.0.0.1 IP address, so it is used for all the debugging and software development purposes. So it is kind of mimicking the process of sending a message from one machine to another machine. So I'm going to use localhost. So this is the convention: Java Datagram Sender, that's the name of the class, then localhost 1234 is the port number, and this is the message. So again, let me show you. So this is the sender program. Okay, so Java Datagram Sender, and this is localhost. The name of the machine is localhost, and 1234 is the port at which the receiver is running, and then this is a string I want to send. So I'm just running it on port 1234. That's the only argument for receiving process. For sender process, you have these three arguments, and then just press enter. Once you press enter, it's going to do what? It's going to package this buffer and then this Datagram packet and send it. So then the other side should receive it. So this is still here. So when I press enter, you see this guy has received it. Okay, so you could do run one more time. You could send anything else you want. The other side should receive it. In this example, we are just illustrating how to send a message and how to receive a message. Okay, so it's one direction, sending from a process and receiving that message in the other process. Okay, so we'll stop the video with this.